Okay. So we've already spent some time looking at graphing prior to this, right? We looked at graphing like quadratics, we looked at graphing polynomials, and I kind of outlined some basic key functions or key pieces that I wanted you to be able to identify. And so similarly, I'm going to identify those things for you now. So key parts of a rational functions graph. All right, and I'm just going to list these things off. All right, so the first thing, a good idea to kind of tackle, is to just identify the domain. Okay, identify that domain. All right, and of course, if you remember, right, back from when we talked about domain, what are the two things that we keep our eyes out for when we are describing the domain of a function? We don't want to all right, and we also don't want to... Oh, okay, well, I mean, we can just, I don't know. Yep. What are our two big domain restrictions? Divide by zero! Yay, we got one. All right, what's the other one? Square root of a negative. There it is, right? So once you get the first one, the other one just comes flooding back to you. There it is. Yeah, so divided by zero, square root of a negative, okay? So I'll put that, gosh, I better put that in parentheses here. Right, or square root of a negative number. I'm just going to put square root of a negative because I want to make sure it fits. Yeah, okay. Okay. I'm sure you all are just teasing me. You all remembered it. You just were like, how long can we make Miss Whitmire sit there in silence? That's okay. All right, so that's the domain, right? And now, I will say, right, rational functions, we haven't seen a whole lot of rational functions with square roots. The big one that we're going to be looking out for here is dividing by zero. We don't want to divide by zero, get that, make it undefined or anything like that. So then, from that, we also want to be able to identify vertical asymptotes. Okay, so how do we know if a function has a vertical asymptote or where it will be?
If the vertical asymptote is 1, it will be the x-axis.
Okay, yep, exactly right. So graphically speaking, right, you won't cross that one exactly. Yep, Shelley. Right, okay, so in other words, it's like where we could potentially divide by zero, right? Yeah, it's those like domain restrictions where you divide by zero. Yep, it's when the denominator equals zero. We'll talk about that some more here too. We also want to identify any holes. All right, so vertical asymptotes and holes, they're two different kind of flavors of discontinuity. All right, remember discontinuity is when your graph either has a jump or a hole or a gap in it, and so vertical asymptotes and holes both kind of create those two different kinds of discontinuities. In addition, we want to be able to identify any zeros, right, or x-intercepts. Any zeros or x-intercepts. We want to identify any horizontal or slant asymptotes. And this is why we're kind of taking 2 days to do this. We're going to focus on problems with just horizontal asymptotes today, and then tomorrow we'll look at some things with slant asymptotes. But again, I feel like this is a concept you guys have been introduced to it before. So, but anyway, we'll do that. Okay. And then, of course, we also want to consider like potentially any sort of additional points. After all that work, we may not have enough information, so we'll say if necessary. And then finally, we graph. So it's just 7 easy steps. Okay, 7 easy steps. I'm going to add in here, by the way, for the vertical asymptotes, what Shelby said there about the whole idea that a vertical asymptote, they occur at, I guess we'll say the domain, at x values where you divide by 0. Okay. Except. There's an exception, and we'll talk about that in a bit. Okay, but right now we'll just go with that. Occur at x values where we divide by 0, but there is an exception to that. Okay, we'll talk about that later when we get to it. Cross that bridge when we get to it. All right, questions on any of that? It's a lot, okay? And a lot of these like pieces are very closely related to one another, right? And so it's very important we kind of keep all these little parts straight when we go about doing this on our own. All right, so let's do an example. Let's just jump in here. All right. So we're going to graph the function f of x equal to 3x over x minus 1. Okay, so we're going to graph the function f of x equals 3x over x minus 1, the quantity x minus 1. All right, so first, let's identify that domain. All right, so I'm looking at this function, and I ask, do we have some domain restrictions here? Could we divide by 0, for example? Yes, when x is 1, okay, right? So if you're like looking at it and you're not really sure, remember you can just take your denominator, set it equal to 0, okay? Set that denominator equal to 0 like we have in the past, and so we get x equals 1, right? And so the domain, okay, we would describe it as what, Sarah? How would we describe our domain then? If we don't want to equal 1, what would our domain actually be then?
Negative infinity
Uh-huh.
to 1.
Uh-huh.
And then 1 to 1.
Yeah, and then union, good, 1 to infinity. Excellent. Thank you. Okay. So there's our domain. It's helpful to remember that. All right, let's do step 2 here. Vertical asymptotes. I'm just going to abbreviate here. And so again, as Shelby said, right, they occur when the x values, when they occur at the x values where we divide by 0. So in this case, it's at 1, right? At the x value of 1, this thing will be divided by 0. It'll be 3 over 0. So we have a vertical asymptote at what x value? Well, it's at 1. Okay, and in fact, x equals 1 is the equation of that vertical line, right? The equation of a vertical line is x equals a number, so x equals 1 is our vertical asymptote. All right, holes, we're going to skip that for now. This one has none. I'll just go ahead and tell you that. This one has none. Okay? This has no holes. The only place a hole is going to occur, potentially, is where we have a domain restriction. But we have a single domain restriction. That domain restriction is at 1, and that domain restriction is already a vertical asymptote. You can't have something be both a vertical asymptote and a hole. They're two separate kinds of discontinuities. We only have one kind of problem area. It's at 1, and that 1 is a vertical asymptote. So we don't have to worry about there being any holes. All right. How about, I'm going to squeeze it in up here. What about zeros? Do we have any zeros? Where? At x equals 0, okay? So when we say zeros, right, what do we really want to know? What's 0 when we say a 0? We want the y value, or the function value, to be 0. We want the function value. So at 0, okay, we do have a 0. But why is 0 a 0 in this case? Is because the function's value at 0 will be 0. Okay, that's too many zeros. I think I should have had to pick a better example, maybe. But yes, so x equals 0. So long story short, you can set the numerator equal to 0. Okay, a fraction, right? This thing's a fraction. A fraction only ever equals 0 when its numerator is 0. Okay, we can only be undefined when our denominator equals 0. So numerator equals 0. So it's x equals 0, like we said. Okay. Or if you want, you can put the coordinates 0, 0, right? You can also put the coordinates. Either one is acceptable there, right? 0, 0, or just x equals 0. All right, good, good, good. Well, let's keep going then. All right, horizontal or slant asymptotes. So, how do we find a horizontal asymptote? What do we do? We've already been doing it, actually. Yeah, James? Yeah, exactly right, okay? Horizontal and slant asymptotes, well, horizontal asymptotes, I should say, so I'll just kind of like draw that out here. It's the limit as x approaches infinity of f of x, or actually I should say and, the limit as x approaches negative infinity of f of x. All right. The idea of asymptotes, right, is that our graph kind of approaches it, gets closer and closer to it, right, but never really touches it. Although actually horizontal asymptotes, your graph can cross a horizontal asymptote. Vertical asymptotes will never be crossed. But the idea is that these things are things that our graph approaches, right? And specifically horizontal asymptotes are what happens as we go really, really, really far to the right and really, really, really far to the left, which is essentially that whole end behavior idea, right? Okay. Which how do you like kind of mathematically go far to the right? You take the limit as x approaches infinity. Mathematically, how do you really go really far to the left? You take the limit as x approaches negative infinity. And that's how we kind of like evaluate those things. All right. So here for the horizontal asymptotes, we're going to take the limit as x approaches infinity of 3x over x minus 1. So I'll get that back on the screen. And so what is that going to equal? Yeah, 3, right? 3 over 1. So 3. So the equation of a horizontal line, y equals 3, is our horizontal asymptote. If we did negative infinity, what would our answer be? Still be 3, right? You have negative, well, it'd be negative 3 times negative infinity over a negative infinity, so negative over negative is still positive 3, so it won't matter. There are some kind of situations where the infinity or negative infinity matter, but we won't be graphing any of those, so we don't have to worry about that. Okay. So, all right. And again, we'll talk about slant asymptotes tomorrow. All right. Additional points. Well, let's just hold off and see if we need that right now. Let's instead go to our graph. Okay. So I'm going to zoom out just a bit. Okay. So let me just go to the graph here. Okay, and I do have graph paper for those of you that, like having the graph paper and stuff like that. So, does anyone want graph paper like right now? Yeah. Okay. Anybody else graph paper? And I've got more, too, for those of you that maybe change your mind. All right, so let's plot some things here. All right, so let's see. 1, 2, 3, 4, 5, 6. Okay, something like that. And we'll start graphing some things. So let's see, vertical asymptote. We have a vertical asymptote at x equals 1. So here's x equal to 1, and we're just going to draw a nice dotted line here. Okay, you can put little arrows at the end if you want to. And I'm going to even label it here, vertical asymptote, x equals 1. Just to have that in there. Okay, we also have a horizontal asymptote, so I'm going to draw that in as well. Horizontal asymptote at y equals 3, so there's 3. Okay. And again, I'm going to label it HA, y equals 3.
Do you have to label those on my wizard test?
If the directions say so, yes. If they don't say so, then no. Okay? I do this because, as I recall from previous times teaching pre-calculus, the CREST, the CREST benchmark, whatever they call it now, it required that you label things, so that's why I'm doing it right now. So yeah, just make sure you read the directions and do what it asks you to do. Okay, that's that's good life pro tip right there. Okay. So the horizontal and vertical asymptote kind of create like the bones of our graph, right? We kind of have now some sort of form and some sort of boundaries and borders that we're going to use to help guide us. But we also have a few points. Well, at least one point. We have the point 0, 0. So I'll go ahead and plot that right there. Okay. So from that single point and the fact that we have kind of our horizontal asymptote here, our vertical asymptote here, we can kind of, that's good enough, I would say. We don't really need to be too crazy there. Ugh, that's not going to be very good, but okay. Something like that. Okay. So that is part of our graph. But of course, we know that with these, or maybe we don't know, but with these rational functions, right, we could potentially have more graph here that we need to think about. So what else do we probably need to do here? We probably do need to get some additional points. So Zach, what do you want to, what kind of x values should we probably pick here?
Probably 2.
Yeah, 2, 3. Okay, we need something on the other side of this vertical asymptote here. Something on the other side. We know we're not going to get any graph up here because then this thing would no longer be a function. All right, so you're not going to get anything up here, but we could get something above the horizontal asymptote. We could get something below the horizontal asymptote. So we want to check that out. So Zach said 2, we'll do 2. So f of 2 is equal to 3 times 2 over 2 minus 1, so we get 6. Okay. And so 2, and then 1, 2, 3, 4, 5, 6. There's another point. And that's enough. Right now we know, okay, the point's up here, so we're going to look something like that. There's a nice little sketch for us. If you want to just get more precision, you can pick more points, right? We could pick more points here on the x-axis to kind of, get a better curve idea. Same thing here. We can pick some more x coordinates here, get a better idea of the curve. But really, that's all we need to get the sketch down at least. Okay. Still quite a bit though. Okay, take some time. Okay. Yes. Go for it. Okay. Questions on any of that? Questions on any of that? Okay. So let's look at one more here. Let's look at one more. And then that'll be it. Okay. Let's do one more, and that'll be it. Okay. All right. Let's now graph f of x equal to x squared minus 3x minus 10 over x squared plus 3x plus 2. Okay. So start with our domain. All right. So Chase, what might be a good place to kind of, what do we need to do here for this domain? We want to look and see if we can, if we possibly do what here? Right, divide by 0. So how can we figure out, I mean, could we divide by 0 here, Chase?
Yeah.
Possibly, right? So how are we going to figure out what those numbers are going to be to make us divide by 0? Okay. Yeah, so let's, actually, you know what, I'm going to go ahead, let's just factor this numerator and denominator here right away, so that's going to be helpful for later. So let's see here. Can you figure out, Chase, how this factors? X minus 5x plus 2, okay. X plus 1 and x plus 2. Okay, great. So we're going to take that denominator, okay, and set it equal to 0. And so then x equals either -1 or x equals -2. Those are our domain restrictions. And so Chase, what would the domain then be? From -infinity to, good, union. Right, don't forget, we have, so
so then you have -2 to -1.
there you go.
And
Yes.
then you have -1.
There, yes, very good. Yep. We want to forget about that little interval between the -1 and the 2, and -2, right? Or -2 and -1, I should say, right? In that order. So yes, don't forget, right? If you have 2 domain restrictions, that splits your interval up into 3 intervals. So splits your number line up into 3 intervals there. Okay, good. All right. So thank you, Chase. We'll move on here. Look at some the vertical asymptotes. Okay, so let's go to oh, Abby's not here, Zoe's not here. How about Megan, what do you say here would be our vertical asymptote? Okay, so that's exactly what we would expect. But when we go to the graph and look at it, right, we don't have 2 vertical asymptotes, we only have 1. Right, so if you look there, -1 and -2, it looks like there's only 1 vertical asymptote. Doesn't look like there's quite 2. So the difference here, and here's where that exception comes in. So here's why I wanted to bring that up to you, okay? Because, actually, you should come back here. Okay. Vertical asymptotes occur at x values where we divide by 0, except when we get 0 over 0, because that indicates a hole. Okay, so holes occur where our function equals 0 over 0. Okay, just to kind of help you out there. All right, so there's the exception, right? So those domain restrictions that we're talking about, they can come in 2 different flavors. You can either have vertical asymptote or hole. And so how do you tell the difference between the 2, right? We have 2 domain restrictions here. We would think that, one's going to be a vertical asymptote, one's going to be a hole in this case. Okay, so Megan, which one of these is actually a vertical asymptote here? What's that? Okay, well, so which one of these does not give us 0 over 0 when we plug it back in? The -2? -2 will give us 0. What's that? Oh yeah, sure, not a problem. So if we look here at the factored form, okay, the factored form, you looked at in the numerator we have an x plus 2 factor, and the denominator we have an x plus 2 factor, meaning that if I were to plug -2 in, it gives 0 and 0. Okay, so then the vertical asymptote is x equals -1. X equals -1 because that would yield just dividing by 0. So this is a vertical asymptote. This is not a vertical asymptote. Okay. So good. Thank you. Okay. Alright, so yeah, only where we divide by 0, not 0 over 0. So that means then we have a hole. Okay. And in this case, it's at x equals -2. But a hole, right, the idea of a hole is it's kind of like a point, but it's a non-point. Alright, it's a non-point, but points, right, have an x-coordinate and a y-coordinate here. So we have the x-coordinate for this hole. How can we come up with the y-coordinate for this hole? What can we do here? Yeah, shall we? Okay, we can find the limit. Exactly right. We can take the limit as x approaches -2 of this thing, okay, and then, direct substitute, all right? So if you look at this right now, we have that x minus 5 times x plus 2 over the x plus 1 times the x plus 2. Okay? Using that limit idea, we can cancel out those x plus 2's, and we're left with just the x minus 5 over the x plus 1. All right? Which now we can evaluate at negative 2. So we get negative 2, plug that in, minus 5 over negative 2 plus 1. So we get negative 7 over negative 1, which is then just 7. Okay. So once you get that x coordinate for the whole, factor your numerator, factor your denominator, cancel, and then substitute and get that matching y coordinate. And so then the coordinate for the whole is negative 2, 7. Negative 2, 7. All right. Alright, so let's look at the zeros then, the zeros. Okay, so James, what would the zeros be for this thing, for this function? X equals negative 1, x equals negative 2.
Sorry, that would be
Careful, those are the domain restrictions, right? So what are...
That would be x equals 5 and x equals...
Okay, so x equals 5, yes. But should we count x equals negative 2 as 0? Right, we have, if it's restricted, it's a domain restriction. So we can't actually be, we can't have a 0 there at negative 2, it's not part of our domain. And the reason it's not part of our domain is because there's a hole at negative 2. Okay, so yeah, the only 0 here is x equals 5. Okay, we don't count that, the negative 2, alright, because again, part of the domain restriction, it's actually a hole, there's a hole there. Okay, so it's just x equals 5 is our 0 there. Just that one. Okay. Alright, additional points. Well, we'll hold off and see if we need that. Oh wait, shoot. I skipped something, I think. I skipped the horizontal asymptote. That's what I did. That's what I did next there. Sorry, horizontal asymptote, number 5. HA. Okay. So let's see here. What do you say, Carter? What's the horizontal asymptote that we have here, Carter? Or do we have one?
Y equals 1.
Yep, 1. Y equals 1. The limit as x approaches infinity of f of x is 1, and so y equals 1 is our horizontal asymptote. Okay, the top and the top degree and the bottom degree are the same. They're both 2. So it's the ratio of those lead coefficients. All right, now additional points. We'll hold off on that. I'll just leave the space there. We'll see if we need it. Okay, so I'll zoom out a little bit here so we can get a nice big old graph. Okay, so let's see here. It looks like I've got a 5, I've got a 7, so I gotta go at least out to 7 for the y-axis and 5 for the x-axis here, so. Okay. It's roughly symmetric there. Okay. And I know some of you guys like to be real economical with your paper and like you don't like to like draw things too big. These are nice to draw kind of bigger though, just because of the the accuracy. Not the accuracy, but I mean just kind of help the graph it. I think it's going to be easier, but it's up to you how you want to do things. Alright, so let's graph these things. So we have a vertical asymptote at negative 1, so there's x equals negative 1. Okay, VA, x equals negative 1. Okay, we have a horizontal asymptote at 1, so... horizontal asymptote y equals 1. And then we have some points. We have a 0, a single 0, right, at 5. So 1, 2, 3, 4, 5. So that takes care of that side. And you also have a hole at negative 2, 7. So negative 2, 1, 2, 3, 4, 5, 6, 7. And so remember, don't draw a point there. It's a hole. So draw an open circle. Okay, I kind of made it very big, but you get the idea. All right, so it looks like we actually have enough information here. We don't need additional points, right? Because we're going to have our graph kind of curve around, do something like that. You could find like the y-intercept here if you wanted to. I mean, it's up to you. You can find additional points. Okay. And so there's our graph, something like that. Pretty little picture. So no need for those additional points. We had a point here on the right, to the right side of that vertical asymptote. We had a non-point, which is just pretty much as good as a point, right, over here to kind of indicate where we're going to go. And so there's our graph. That's what it's going to look like, something like that. Okay. Any questions on anything like that? All right, then let me give you all your assignment here.